In the heart of every ship, power is the lifeblood that keeps systems running. Today we learn the critical process of generator synchronization. Synchronization is the process of matching the parameters of an incoming generator with those of the live bus bar before connecting them. Before we start, ensure the prime mover of the incoming generator is running and has reached its rated speed. Check the engine parameters like lube oil pressure, jacket water temperature, and exhaust temperatures to ensure the engine is healthy. Now move to the engine control room and locate the main switchboard section for the incoming generator. The first parameter we must match is frequency. The incoming generator, U0027S frequency, must be slightly higher than the bus bar frequency. Use the speed governor switch to adjust the speed of the engine. Increasing the speed increases the frequency. Observe the frequency meter on the switchboard. If the bus is at 60 Hz, aim for 60.2 Hz on the incoming machine. A slightly higher frequency ensures that the generator takes on some load immediately upon closing the breaker, preventing a reverse power trip. Next, we look at the voltage. The voltage of the incoming generator must be equal to or slightly higher than the bus bar voltage. Use the automatic voltage regulator or a VR control to adjust the voltage. If the bus voltage is 440 volts, the incoming generator should ideally be around 4-100-40-5 volts. Once frequency and voltage are stabilized, use 0 to 7s time to use the synchroscope. Turn the selector switch to the incoming generator. The synchroscope measures the phase angle difference between the incoming generator and the bus bar. The needle will start rotating. If it rotates clockwise, the incoming generator is faster. Anti-clockwise means it is slower. We want the needle to rotate slowly in the clockwise direction, about 1 revolution every 5 to 10 seconds. This slow rotation indicates that the frequencies are very close and we are approaching the point of synchronization. Look at the phase sequence lamps as well. They should brighten and dim in sequence, providing a secondary check for phase matching. The most critical moment is when the needle reaches the 12:00U0027 clock position. This indicates the phases are perfectly aligned. However, due to the closing time of the circuit breaker, we must initiate the closing command slightly before the 12:00U0027 clock position. Typically, we press the close button when the needle is at the 11:00U0027 clock position, moving towards 12. Watch for the breaker, closed indication lamp. You should also hear the mechanical thud of the breaker engaging. Immediately after closing, observe the kilowatt meter and the ammeter. The generator should now be sharing the system load. But we aren't U0027T done yet. Now we must balance the load between the generators. Increase the governor speed of the newly connected generator while simultaneously decreasing the speed of the other generators. Monitor the kilowatt meters. Ensure the total load is shared proportionally according to the capacity of each generator. Don't U0027T forget to check the reactive load sharing as well, which is managed by adjusting the AVRs of the machines. Once the load is balanced, turn off the synchroscope and return any selector switches to their neutral positions. Keep monitoring the parameters for a few minutes to ensure stability and that no alarms are triggered. Congratulations, you have successfully synchronized and load shared a generator. Safety and precision are key to a reliable power plant at sea.